NCERT Class 10 Science, Chapter 2, Acids, Bases, and Salts. Exercise questions answers. 1. A solution turns red litmus blue, its pH is likely to be A1, B4, C5, D10. Answer: D10. Explanation. Times a solution that turns red litmus blue is basic in nature. Times the pH scale ranges from 0 to 14 where O acidic solutions have a pH less than 7. O neutral solutions have a pH of 7. O basic alkaline solutions have a pH greater than 7. Times among the given options, pH 10 is the only basic solution, so the correct answer is D10. 2. A solution reacts with crushed eggshells to give a gas that turns lime water milky. The solution contains A NaCl, B HCl, C LeCl, D KCl. Answer: B HCl hydrochloric acid. Explanation. Times eggshells contain calcium carbonate CaCO. Times when calcium carbonate reacts with an acid, it produces carbon dioxide co-gas. Times reaction with hydrochloric acid HCl, CaCO3 plus 2HCl CaCl2 plus O2 plus H times the released co-gas turns lime water CaO milky due to the formation of calcium carbonate CaCO, CaO2 plus O2 CaCO3 white precipitate plus H2 times. Therefore, the correct answer is HCl hydrochloric acid. 3. 10 ml of a solution of NaOH is found to be completely neutralized by 8 ml of a given solution of HCl. If we take 20 ml of the same solution of NaOH, the amount of HCl solution the same solution as before required to neutralize it will be A 4 ml, B 8 ml, C 12 ml, D 16 ml. Answer: D 16 ml. Explanation. Times neutralization reaction, NaOH plus HCl NaCl plus H2O Now plus HCl NaCl plus times if 10 ml of NaOH requires 8 ml of HCl, then 20 ml of NaOH will require 2010 times 8 equals 16 ml of times. Correct answer: D 16 ml. 4. Which one of the following types of medicines is used for treating indigestion? A. Antibiotic, B. Analgesic, C. Antacid, D. Antiseptic. Answer: C. Antacid. Explanation. Times indigestion occurs due to excess acid HCl in the stomach. Times antacids are mild bases that neutralize this acid and relieve indigestion. Times examples of antacids: O magnesium hydroxide milk of magnesia, O sodium bicarbonate baking soda, O calcium carbonate Tums tablets. 5. Write word equations and then balanced equations for the reaction taking place when a dilute sulfuric acid reacts with zinc granules. Times word equation: sulfuric acid plus zinc sulfate plus hydrogen gas. Times balanced equation: H2SO4 plus ZnZnSO4 plus B dilute hydrochloric acid reacts with magnesium ribbon. Times word equation: hydrochloric acid plus magnesium chloride plus hydrogen gas. Times balanced equation: 2HCl plus NGMgCl to NGMgCl2 plus H2. C dilute sulfuric acid reacts with aluminium powder. Times word equation: sulfuric acid plus aluminium sulfate plus hydrogen gas. Times balanced equation: 3H2SO4 plus 3H2SO4 plus 2Al2SO4 3 plus 3H2. D dilute hydrochloric acid reacts with iron filings. Times word equation: hydrochloric acid plus iron chloride plus hydrogen gas. Times balanced equation:
6HCl plus 2Fe is equal to 2FeCl3 plus 3H2.
6. Compounds such as alcohols and glucose also contain hydrogen but are not categorized as acids. Describe an activity to prove it. Answer: to prove that alcohols and glucose contain hydrogen but are not acids, we can perform an experiment to test their electrical conductivity. Activity: testing the conductivity of alcohol and glucose solutions. Materials required: times beaker, times battery, times connecting wires, times bulb, times switch, times 2 iron nails, times solutions of glucose, alcohol, and dilute hydrochloric acid HCl. Procedure: 1. Set up the apparatus. Take a 100 ml beaker and fix 2 iron nails on a cork. Connect the nails to a battery, switch, and a small bulb using wires. 2. Testing an acid HCl. Pour dilute hydrochloric acid HCl into the beaker. Dip the iron nails into the acid and turn on the switch. Observation: the bulb glows, indicating the presence of free H ions, which conduct electricity. 3. Testing glucose solution. Now, pour a glucose solution into the beaker and dip the iron nails. Turn on the switch and observe. Observation: the bulb does not glow, indicating that glucose does not release H ions in water. 4. Testing alcohol solution. Replace the glucose solution with an alcohol solution and dip the nails. Turn on the switch and observe. Observation: the bulb does not glow, proving that alcohol also does not release H ions in water. Observation table. Solution used bulb glows. Reason: dilute HCl yes produces H ions, conducts electricity. Glucose solution no does not produce H ions. Alcohol solution no does not produce H ions. Conclusion: times acids like HCl release H ions in solution, which conduct electricity. Times glucose and alcohol contain hydrogen, but do not ionize to release H ions, so they do not behave as acids. Times this proves that not all compounds containing hydrogen are acids. This activity demonstrates that glucose and alcohol are not acids despite having hydrogen in their structure. 7. Why does distilled water not conduct electricity, whereas rainwater does? Answer: times distilled water is pure water that does not contain any dissolved salts, minerals, or ions. Times electricity is conducted by the movement of free ions in a solution. Since distilled water lacks ions, it does not conduct electricity. Why does rainwater conduct electricity? Times rainwater is not pure water, it contains dissolved gases like carbon dioxide CO, sulfur dioxide SO, and nitrogen oxides NO from the atmosphere. Times these gases dissolve in rainwater and form weak acids, such as carbonic acid HCO,
CO2 plus H2O gives H2CO3.
sulfuric acid HSO and nitric acid HNO may also be present. Times these acids release free H and other ions into the water, making it a good conductor of electricity. Conclusion: times distilled water does not conduct electricity because it lacks ions. Times rainwater conducts electricity because it contains dissolved acids and salts, which release free ions that allow electric current to pass through. 8. Why do acids not show acidic behavior in the absence of water? Answer: times acids do not show acidic behavior in the absence of water because they do not ionize to release hydrogen ions H without water. Times the acidic property of acids is due to the presence of H hydrogen ions, which are responsible for their ability to turn blue litmus red and react with bases. Times in water, acids dissociate as follows. Example: dissociation of hydrochloric acid HCl in water.
HCl plus H2O gives H2O plus Cl.
Here, HO hydronium ion or H ions are formed, making the solution acidic. Why do acids not behave as acids in the absence of water? Times in the absence of water, acids remain in their molecular form and do not produce H ions. Times since no free hydrogen ions H are available, the acid does not exhibit acidic properties such as changing the color of indicators litmus, methyl orange, phenolphthalein, reacting with bases to form salt and water, conducting electricity. Example to demonstrate this concept. Activity, effect of water on acidity. 1. Take dry HCl gas in a test tube and bring a blue litmus paper close to the mouth of the test tube. Observation: the litmus paper does not change color. Reason: no H ions are present in dry HCl gas. 2. Now, dissolve HCl gas in water and test again with blue litmus paper. Observation: the blue litmus turns red, showing acidic behavior. Reason: HCl ionize in water to release H ions, making the solution acidic. Conclusion: times acids show acidic properties only in the presence of water because H ions are released. Times without water, acids do not ionize and do not exhibit acidic behavior.
9. 5 solutions A, B, C, D, and A when tested with a universal indicator showed pH is 4, 1, 11, 7, and 9 respectively. Which solution is neutral? Solution D, pH equals 7 is neutral. A pH of 7 indicates a neutral solution, such as pure water. B, strongly alkaline. Solution C, pH equals 11 is strongly alkaline. A pH above 10 indicates a strong base, like sodium hydroxide NO or potassium hydroxide CO. C, strongly acidic. Solution B, pH equals 1 is strongly acidic. A very low pH, close to 0, indicates a strong acid, such as hydrochloric acid HCl or sulfuric acid HSO. D, weakly acidic. Solution A, pH equals 4 is weakly acidic. A pH between 4 and 6 indicates a weak acid, such as acetic acid vinegar or citric acid lemon juice. A, weakly alkaline. Solution A, pH equals 9 is weakly alkaline. A pH between 8 and 10 indicates a weak base, such as ammonium hydroxide NHO. Arranging pH values in increasing order of hydrogen ion H concentration. Higher H concentration means lower pH. Thus, the solutions are arranged in increasing order of pH, decreasing acidity, increasing basicity. B, pH equals 1, less than A, pH equals 4, less than D, pH equals 7, less than A, pH equals 9, less than C, pH equals 11. Conclusion. Solution pH value nature. B1 strongly acidic, A4 weakly acidic, D7 neutral, A9 weakly alkaline, C11 strongly alkaline. 10. Equal lengths of magnesium ribbons are taken in test tubes A and B. Hydrochloric acid HCl is added to test tube A, while acetic acid CH2 is added to test tube B. Amount and concentration taken for both acids are the same. In which test tube will the fizzing occur more vigorously and why? Answer. Fizzing will occur more vigorously in test tube A with hydrochloric acid HCl. Explanation. 1. Reaction of magnesium with hydrochloric acid HCl. OHCl is a strong acid and fully ionizes in water, producing a high concentration of H ions. Reaction equation. Mg plus 2 HCl right pointing arrow MgCl2 plus. Since more H ions are available, the reaction proceeds rapidly, releasing hydrogen gas H quickly, causing vigorous fizzing. 2. Reaction of magnesium with acetic acid CH2. Acetic acid is a weak acid, meaning it partially ionizes in water and produces fewer H ions. Reaction equation. Mg plus 2CH3 right pointing arrow CH3COO 2 megagrams plus H2 up. Since fewer H ions are available, the reaction occurs slowly, producing less hydrogen gas H at a slower rate, resulting in less fizzing. Conclusion. Test tube A, HCl, right pointing arrow more vigorous fizzing, strong acid, more H ions, faster reaction. Test tube B, CH2, right pointing arrow less fizzing, weak acid, fewer H ions, slower reaction. Overall, the reaction with hydrochloric acid HCl is faster and more vigorous than with acetic acid CH2. 11. Fresh milk has a pH of 6. How do you think the pH will change as it turns into curd? Explain your answer. Answer. As fresh milk turns into curd, its pH will decrease, become lower. This is because lactic acid is produced during the curdling process, making the milk more acidic. Explanation. 1. Fresh milk has a pH of about 6, meaning it is slightly acidic. 2. When milk turns into curd, bacteria, lactobacillus, ferment the lactose, milk sugar, into lactic acid CHO. 3. Lactic acid increases the acidity, causing the pH to drop below 6, usually in the range of 4.5 to 5.5. 4. The lower pH leads to the coagulation of milk proteins, casein, forming curd. Chemical reaction. Lactose, C12H22O11, plus bacteria right pointing arrow lactic acid, C3H6O3. Conclusion. The pH of milk decreases as it turns into curd due to the formation of lactic acid. This increased acidity helps in the coagulation of milk proteins, leading to curd formation. Final pH of curd, around 4.5 to 5.5, more acidic than fresh milk. 12. A milkman adds a very small amount of baking soda to fresh milk. Why does he shift the pH of the fresh milk from 6 to slightly alkaline? Answer. Baking soda, sodium bicarbonate, NaCO, is a weak base. When added to fresh milk, it neutralizes some of the natural acidity, mild lactic acid present in milk. This increases the pH, making the milk slightly alkaline, above pH 7. This helps in preventing quick spoilage, as bacteria that cause milk to sour grow slower in alkaline conditions. B. Why does this milk take a long time to set as curd? Answer. The curdling process occurs when lactobacillus bacteria convert lactose, milk sugar, into lactic acid, which lowers the pH and causes milk proteins, casein, to coagulate, forming curd. Since baking soda neutralizes some of the acidity, the milk remains less acidic for a longer time. As a result, the pH does not drop quickly, and the curd formation process slows down, taking a longer time to set. Conclusion. Baking soda increases the pH of milk, delaying spoilage. Higher pH slows down the production of lactic acid, making curd formation slower. 13. Plaster of Paris should be stored in a moisture-proof container. Explain why. Answer. Plaster of Paris, POP, is calcium sulfate hemihydrate, CaSO, 1/2 HO. It is highly hygroscopic, meaning it absorbs moisture from the air. If exposed to moisture or water, it reacts to form gypsum, CaSO, 2HO, which is a hard solid and loses its ability to be molded. Chemical reaction. Caso 4 dot operator 1 2H2O plus water right pointing arrow Caso 4 dot operator 2H2O. Plaster of Paris, POP, absorbs water and turns into gypsum, hard solid. Why is this a problem? POP is used for making molds, casts, and construction materials because it can be shaped when mixed with water and hardens upon drying. If it absorbs moisture in storage, it hardens prematurely and cannot be used for its intended purpose. Conclusion. POP must be stored in a moisture-proof container to prevent it from reacting with water and losing its molding property. This ensures longer shelf life and usability. 14. What is a neutralization reaction? Give 2 examples. Answer. A neutralization reaction is a chemical reaction in which an acid reacts with a base to form salt and water. This reaction eliminates the acidic and basic properties, resulting in a neutral solution pH equals 7 in ideal cases. General equation for neutralization. Acid plus base right pointing arrow salt. Examples of neutralization reactions. Example 1. Reaction of hydrochloric acid HCl with sodium hydroxide NO. HCl plus NO right pointing arrow NaCl plus HCl acid reacts with NO base to form NaCl, salt and water. This is a strong acid strong base neutralization and the resulting solution is neutral pH equals 7. Example 2. Reaction of sulfuric acid HSO with calcium hydroxide CaO. H2SO4 plus CaO, 2 right pointing arrow Caso 4 plus 2H2OH. HSO acid reacts with CaO base to form calcium sulfate, salt and water. This is a strong acid strong base neutralization, commonly used in industrial applications. Everyday life applications of neutralization. 1. Treatment of indigestion right pointing arrow antacids, bases like MgO, neutralize excess stomach acid HCl. 2. Soil treatment right pointing arrow farmers add slaked lime CaO to acidic soil to neutralize it. 3. Toothpaste use right pointing arrow neutralizes acid in the mouth that causes tooth decay. Conclusion. A neutralization reaction occurs when an acid and a base react to form salt and water. This reaction is used in daily life applications, including medicine, agriculture, and industry. 15. Give 2 important uses of washing soda and baking soda. Answer. A. Washing soda, sodium carbonate, NaCO, 10HO. Washing soda is a basic salt and a strong cleaning agent. 2 important uses. 1. Softening hard water. Washing soda removes permanent hardness of water by precipitating calcium and magnesium ions as insoluble carbonates. Reaction.
CaCl2 plus Na2CO3 pointing arrow CaCO3 plus 2NaCl.
This helps in making soap work better in hard water. 2. Manufacturing glass, paper, and soap. Glass industry. Used in the production of glass and ceramics. Paper industry. Helps in paper pulp processing. Soap industry. Used as an ingredient in detergents and soaps. B. Baking soda, sodium bicarbonate, NaCO. Baking soda is a mild base used in cooking and medicine. 2 important uses. 1. Used in baking, leavening agent. Baking soda releases CO gas when heated or mixed with acid, making cakes, bread, and pastries soft and fluffy. Reaction.
2 NaHCO3 pointing arrow Na2CO3 plus H2O plus CO2.
2. Used as an antacid, relieves indigestion. Baking soda neutralizes excess stomach acid and provides relief from indigestion and acid reflux. Reaction.
NaHCO3 plus HCl gives NaCl plus CO2 plus H2O.
It is the main ingredient in antacid tablets and ENO. Conclusion. Washing soda is used for softening hard water and manufacturing glass, soap, and paper. Baking soda is used in baking and is an antacid to relieve acidity. Now, detailed answers to all 20 questions are complete. Make sure to read them carefully for your exam. If you have any further doubts, feel free to ask us. Don't forget to like, share, and subscribe to the channel for all chapter-wise solutions and more study videos. See you in the next one.